Okay, in this video we'll go through my process and theory for stripping down a Swiss Army knife without causing any harm to any of the components, except the rivets. I'll warn you, this is a little bit lengthy and possibly not quite as exciting as the rest of the videos in this series. So if you're more interested in how the knife was actually made, you may want to skip this one. But this, I think, is really useful information for anyone attempting a similar project, so I decided to make this video anyway. Alright, how to take apart a Swiss Army knife. So, the Swiss Army knife is held together with these rivets, 4 of them. The rivets have these rings around them, and the rings are not just there for any old reason. They have a machined feature around the top edge, a kind of barbed undercut, which grabs hold of the scales. So the plastic scales have these bores, parallel walled bores molded into the plastic, cylindrical bores. And these barbed rings press into those bores when you put the scale on, and then if you obviously forces pulling the scale off are acting against that barbed edge. I'll take a shot down the microscope so you can see what I'm talking about. So these rings, you've got to try and preserve them because they're difficult to buy. The only source I could find was a shop on Alibaba that was out of stock, and sackparts.com in America, which had really slow international shipping. So I'm in the UK, so neither of those were options. So I'm fortunate enough to have machining facilities, so I could make new ones if I had to, but I'm going to try and keep as many of them intact as possible. The inside surface is not as critical as the barb, so you want to really, we're going to preserve both surfaces, but we really want to preserve that barb. So when you're using a Dremel or something like that, which I will use because it does a good job at removing these, you've got to be really careful not to accidentally skip outside the ring and then skate around the ring and damage it. I did that on one of these rivets on another knife that I took apart. So I'm just going to draw the situation actually, because that'll make things clearer. So the situation is, if this is the scale, say this top surface here, rivet. So the rivet shaft comes up through the plate like this. And the ring on the outside surface is shaped like this. It comes up, out, and then it has about a 45, and then that's its top surface like that. And that barbed, it's not quite well, yeah, that's an undercut, yeah. So that's 90 degrees. Yeah, that's enough just to grab the plastics. Obviously, when you press the plastic scale on, so if I kind of draw the plastic scale in blue, the plastic scale has this bore, like I was talking about, this cylindrical bore here. As that presses on, the barb wants to go one way but not the other. So yeah, you've got a good strong retaining force there. Side effect of this is that when you push the scale off, this barb digs in and scrapes material off the inside of the bore, and yeah, from that point on, that in my view, that scale is good for the. You might as well file it in the round cabinet, which is fine because they're cheap. Yeah, if you do replace a scale that's already been on a blade, on a knife rather, it's probably worth gluing it on, which is a bit sad, but I don't know. Yeah. Otherwise, the retaining force just isn't as strong. On the inside surface of these rivets, there's a taper like this that goes most of the way to the bottom, and then there's a straight section. So that looks like that. It's a relatively gentle taper, and the rivet gets peened into that recess. On one side, the rivet's actually pre-machined or swaged. It's already got its taper formed, and you can see that because these ones are really neat on the top surface. So those are already well formed. And if you have a look at one that I've already removed, I don't know if you can see this in this shot, but yeah, that's already got a really nice sort of countersink. I don't know what the angle of that is. I need to check that out. But yeah, so that's already formed that side of the rivet, and then the other side is peened. So we're going to be attacking it from the peened side. Doesn't particularly matter which side you attack it from, but the peened side happens to be the side with the corkscrew on most knives, and you really want that upwards because well, you'll see if you've got a sort of fixture with that on the bottom, the knife doesn't sit flat, and it's annoying. So yeah, so that's that really. So yeah, so that rivet is then peened into that recess, and yeah, and it's more or less flush to the top of the recess. So what we're going to do, we're going to attack this in sort of more or less 3 stages. First off, we're going to use a cutting burr in the Dremel. It's a really high speed, small diameter cutting burr. It's about 1.5 mil, I think. By the look of it, yeah, 1.5 mil. This is a bud burr, so that has a profile. Doesn't really matter particularly. This one has a kind of shape like that, and it has cutting edges. You can also get spherical ones, which obviously just, or ball burrs as they're called. They just neck in a little bit earlier like that. Either of them will do. And we're going to use that to cut into the top of the rivet and make a little divot like this. So we're just going to cut a divot and try and get it on axis down the center of the rivet. And the reason we're using a burr is that we can kind of iteratively make this divot. So if we make it a bit off center, we can then correct and cut sideways, because that's exactly what these burrs are designed to do. They'll cut downwards slowly, but they'll cut sideways much more quickly. So we can use that to kind of establish a divot and then center it by using the sideways cutting action of the burr. I'd recommend doing all of this with as much light and magnification as you can. I'll do it down a microscope because I have a microscope. If not, just yeah, maybe a magnifying glass or yeah, whatever you've got. So that's the starting point. We're then going to drill out the rivet, and what we're trying not to do is touch the inside surfaces of the ring. So what we'll do is, using the divot to center the drill bit, that's the reason that we're going to cut this divot. We're then going to drill, and we'll probably, I don't know, we might do it in 2 steps. So maybe, let's say we'll drill, I don't know, say 1.5. I think that's the diameter I used last time. We'll drill just down so that we've cleared this this surface of the scale, or the liner, whatever you want to call it. So we're going to draw that diameter down. So now, if you'll notice, if we sort of shade the cross section of the I'll do it on one side. The rivet. We've now thinned it down. So instead, we've taken out all of this material in the middle, and we've just got this thin skin. And we're gonna remove a little bit more of that. So I would probably drill in 2 steps. So in the worst case rivet, so the smaller rivets, this dimension here is 2.2 mil. And I think I originally drilled that out 1.5. So that was my starting diameter. And then I drilled 1.7. So I kind of came in with another drilling operation. Like that. So now we're down to just this bit of material here that's left on each side. And that's thin enough that we can just snap it off. And the advantage of snapping it off is that there's no chance of us damaging these inside surfaces, because we haven't, hopefully if we've drilled concentrically, we haven't touched these inside surfaces yet. So that's the advantage of this approach. So how do we grab hold of this and snap it off safely? Well, the easy way of doing it is to just take your drill bit that you've just used to drill the hole, or maybe the next size up. So let's say we've drilled this. It's getting a bit of a busy diagram here, isn't it? Let's just drill that shade that's sort of in blue here. So we've now got a bore that's this diameter. Let's say we've drilled that out 1.8. You can basically drill as large as you dare, but don't go too large, because obviously the risk gets larger that you start chewing into the edges of the ring, which is what we're trying to avoid. So say we've drilled that 1.8. What I then do is I stick the back end of the drill bit, so the 1.8 mil drill bit, I just stick it down the hole, down to, not too far, but down to, so the bottom of the end of the drill bit is at this interface, basically, where the edge of the plate is. And then you can just bend it over, maybe sort of give it a bit of a wiggle, or sort of gyrate it around until the rivet snaps, because now the rivet is basically just this tube here, right? So it's just this tube is the only kind of remaining bit here, and we'll just kind of shear through there and there, and the whole thing will come away, and then we can just remove the little bit of tube from the inside of the ring at our leisure, when it's not attached to a knife, and we can get to both sides, and get to the other side rather than the peen side. So yeah, that's the sequence basically. So drill the divot, drill a hole down the middle using the divot as a center. Drill it out a bit more, as big as you dare, and then finally snap it off by using a drill bit as a lever. So that's enough chat. Let's do it. All right. So it's important that we use a burr with very fine teeth. This is a very fine one. I don't know if how you actually quantify that. There's probably some kind of measurement system, but I don't know it. But this is I don't know, probably 20 or 30 teeth around the perimeter of this thing, and it's only 1.5 mil diameter, so it's very, very fine cut. And the advantage of that is it's much less likely to skip. If you have one with big teeth, it's much more likely to dig into the material, skip, and it's a lot less controllable, whereas this thing can just very slowly bore your way down. And if you have a decent quality Dremel, it'll go up to maybe 20 or 25,000 RPM, so you can still cut at a reasonable speed even with a very fine-toothed tool. So just put that in the Dremel. Put it on maximum beans. Yes, this one goes up to 35k, which is pretty damn quick. I mean, who knows how accurate that actually is, but sounds pretty horrendous, like the dentist. So I'm just going to make a divot now. And as I mentioned, I'm going to do it under the microscope. Right, a bit tricky to shoot this down the microscope, but yeah, here you can see the divot in the middle, and you can see that its edge is nicely concentric with the edge of the pin. So that inner line there is the edge of the divot. And if I just gently try to adjust the focus down to the bottom of the hole, you can see there that's the bottom of the hole, and that's pretty concentric. So yeah, nice job there. This hole is, like I say, 1.5. Well, it's probably because the burr can obviously cut significantly oversized. I think probably this hole is about 1.7, 1.8 at the top, and it's kind of dished in a hemispherical kind of bowl shape, and towards the it kind of narrows to about 1.5 mil, and then with obviously a hemispherical tip. So yeah, gonna drill that 1.5 now. See how that goes. Okay, I've just made this little block here with some clearance holes in the pattern of the rivets on the knife, so that I can rest it and have a nice stable flat surface. And yeah, like that. So that's nice and stable. And I'm just going to drill that out 1.5. Get it lined up. Right, so I've now drilled that out to 1.8. It still looks good, still looks very concentric. And I reckon now it'll snap off because it's 2.2 wide, minus 1.8, it's only 0.4 of total diameter, so 0.2 mil of wall thickness on this tube, and that's if it's perfectly concentric, which it won't be. So yeah, hopefully it'll be about spot on. So I'm going to put the back of the drill bit in about the depth of the ring. It's about 2 and a bit mil, and then I reckon with a bit of gentle persuasion, there we go, that snaps off. And that looks absolutely lovely. I can see there's still a tube all the way around, so it's not eccentric. If it was eccentric, obviously it would be the drill bit would have bitten into the edge of the inside of the ring, but that's not the case. I can see that the tube there is it's a full circumference. It goes all the way around. So yeah, that's perfect. So we're going to do that on the other two, and then the third one we can just sand off. So that's easy. Right, so those rivets are off. The next stage is to remove the little one that doesn't have a ring. This is just a kind of hemispherical thing peened over at both ends. Well, actually that one's formed and that one's peened. I'm just going to sand this off with the Dremel sanding drum. If it was flat, I would just file it off, but because of this raised region here, this sort of joggle in the side of the plate here, and it's easiest just to come in and sand it off. First, some prep. I'm going to tape up the scissors because previous experience that helps because they've got a tendency to kind of spring apart. So just tape them up, lobster style. So that's that, and fold them away now. And what else? Yeah, that's about it really. Just bear in mind the whole thing's under spring pressure, so it's going to want to fly apart when time comes. Last time I actually taped the whole thing up before removing the rivets. Yeah, let's do that again. I think that was a good idea. So a little bit around here. Just keep that under control. And I'm going to do this. I think yeah, it's already. No, it's not coming apart. I thought it was coming apart. I'm going to put a bit, I think, under the. More or less the first parts to come out anyway, those that corkscrew, so I think I'll just leave that outside like that. Yeah, that's as much as I'm going to do with that. And then I'm also going to come in and tape up around these rivets so that I can have a bit of protection for sanding it. Oh, out of tape. Oh, there's more tape here. Yeah, what am I going to do? I think I'm going to 2 bits like that. Like that, that'll be all right. I'm wondering if I might just, yeah, I'm going to just give myself an extra layer just because I've got a pretty aggressive sanding drum. It'll give me a little bit of warning. Hopefully I won't scuff up the plate. Right, that'll do. Right, it's going to start sanding that now. Takes it to the table pretty effectively. You want to be very carefully braced to avoid going too far with this. Can be very careful. See, that's starting to get down to the bottom. Just starting to touch the tape. Oh, I'm just through the tape. Just a tiny smidge. Okay, I'm going to stop there. That'll probably do. You don't have to get it absolutely flat down to the plate because obviously the edges will shear off. So I'm going to peel off the protective bit of tape and leave the clamping tape behind. Yeah. So it's pretty good. It hasn't touched the metal really at all, and that rivet will give up pretty easily, I would expect. So now we're going to start taking it to bits. First step, I think I will... last time I had a bit of trouble with the edges of the rivets catching on things on the way through. I'm not too worried, but I am worried about the plastic magnifying glass. Got to be a bit careful with that. So I think I'm just going to crush the edge of this slightly to take that burr off. Just to go with the parallel pliers. That's pretty good. Hopefully it won't catch. I'm gonna... I think I might try and sort of take pieces off this time. Last time I just pulled the rivets through. That was a little bit chaotic. So this time maybe I'll try and lift pieces off. I don't know. It's probably also going to be chaotic. Kind of chaotic no matter what you do, really. Just trying to protect the magnifying glass, really. That's the only thing I'm worried about. Yeah, let's try a new approach. Let's try lifting pieces off. Who knows how that's going to go, but whatever. So, yeah, having carefully applied this this tape here, maybe I'm going to take it off. The reason I'm doing this is I just don't want to pull this gnarly rivet through that piece of plastic on the magnifying glass, because yeah, it might be a bit chewy. Anyway, let's take this pin out, because that'll relieve all of the spring force, and then we can take things off in a less chaotic way, hopefully. Just do that. So, yeah, I've got my little standoff block here. What's going on here? Oh yeah, it's mirrored. Yeah, it's confusing, isn't it? Yeah, cool. So that's nice and stable. And we'll just drift that out. I've got a pin punch here, parallel punch. Nice and centered. Cool. Okay, that's that. So now, once you've removed one pin, all the spring forces are relieved as long as you've taped up the scissors. So yeah, let's crack it open. I mean, yeah, we know where the corkscrew goes, so that's not too much of a problem if we just take that out. Right. And I think that should be safe to carefully lay down. Cool. Well, that didn't explode. So now what I'm going to do is lay each piece out in an organised way so that I've got some sort of record. Not that it's that critical now, but well, no, it's pretty important. Yeah, you can see the tops of those rivets are grabbing hold of this plate. Okay, so what I'm going to do... what am I going to do? So that middle one's already down a smidgen. So I think I'll just tape it back up again. Just for a sec. Then just nudge these down through that top plate, and that should hopefully kind of collapse those burrs on the edges of these pins. Make it a bit easier to manage. Oh, yeah, that was easy. Cool, I'm going to hammer it through the top tool as well, because that stainless steel, it's got a bit of beans, it'll squash it nicely. Okay, cool, so carefully just untape it again. Brilliant. Oh yeah, it's all coming apart. So yeah, so just each piece I'm just going to carefully lay out. So back spring. I know the order of these blades. Actually, I'll take a quick photo of that. Oh no, you're recording. Alright, well, I guess I've got the recording. So the little blades on top, yeah, we kind of know that. Cool, that's really, it's really stuck. So the end of this rivet is causing some trouble. It's kind of squished into this plate, this little shim section here, so I have to knock it down a little bit more. Maybe some parallel plier action might just help squish it a bit. I don't want to keep just drifting it down because the point of this operation is I want to clear up the end of this so that I can take the plastic piece off without causing any trouble. I also don't want to bend this shim. Oh yeah, it's coming off. Excellent. I'm going to try and take the next layer off. Squish this slightly more. Ooh. Hook's escaping. Essentially trying to squish the end of this pin from all directions to kind of taper it down a bit, make it a bit better behaved. See if I can take this plate off. Yeah, a similar story with this pin over here. Got an idea. Yikes. Well, there you go. So I just kind of sanded the tops of these pins, so hopefully they'll be less badly behaved. Let's see. Yeah, a little bit. Still kind of annoying. Careful not to bend this plate. not quite. Well, I suppose it's only this one that I'm that concerned about, because this is the plastic eating one, so let's drive these two down a smidge. Let's see if this one will lift off. Well, there we go. Nice. Oh yeah. Thought I'd lost something. Cool. So we've got a nice, smooth, well, relatively nicely deburred, nice parallel pin there, so that won't scar up the inside of the magnifying glass. Right. Okay. So let's take the plate off. Don't quite want to come off. Okay. Another plate. Cool. Got Phillips. Bank spring. Magnifying glass. And another plate. Seems to be skewed on that shaft for some reason. Oh, Christ. It's interesting that it's bound up on this plate, not the others. Must be a tolerance thing. we go. On the plate. Then we got our ball. Just that way around. How's that going? Yeah, that goes over. Oh, well, I've got a photo of that. Don't know which one of those goes over the other one, but we'll figure it out. Brilliant. And we're there. That's from the other knife, don't get confused. We'll put these away before all hell breaks loose. The middle one is a bit resistant, isn't it? I don't know what we do about that. Yep, works. Save our little, well, save all these parts. Brilliant. I should probably just snip them off at the top, but never mind. I thought that would leave too big a burr. Right, cool. That's the back. So that goes like that, I think, doesn't it? And that's what the Explorer looks like when it's all stripped down. You can see each layer and each liner, all the tools from each layer, all laid out.